Hey guys, let's talk a little bit about the structured query language, SQL, for the GIS professional. First of all, what is SQL? Another 2 hours with Vin Diesel and fast cars? No, probably not. The structured query language, yeah, that's what it is. It's this structured query language is the language used for querying and filtering database tables. You find this language all over the place. It's the standard for querying databases. So you'll find it in Oracle and SQL Server and um, PostgreSQL. And you find it inside of ArcGIS, right? Now, inside ArcGIS Pro, you only find a portion of SQL in the interface. And where do you find it? You find it up here when you're doing a select by attributes. This is actually running SQL. You have a nice interface for building that SQL, but if you say something like, for example, select all the parcels that are in a city called Olympia, you can slide this SQL slider over and you can see the actual code. Now, what you're seeing here is just a portion of SQL. It's the where clause. There's a lot of other bits around SQL which we can get access to if we're, for example, writing Python scripts that call data from the attribute table or that pull data from a table, or if we're writing some functions inside an FME transformer that where we can pass a full SQL statement into the database. So there are many cases where we can use the full SQL statement. But again, here in ArcGIS Pro and in AGOL and Portal, we're just seeing what's called the where clause. But there's still lots of cool tricks you can do in here if you slide that slider over. So let's talk about that a little bit. So why spend a few minutes watching this video to learn about SQL? Because there's nothing exciting on TikTok today. There's no new funny cat videos. No, because it's a powerful language for data QC and analysis, and every GIS professional ought to at least know a little bit about SQL, more than what you can just use in that select by attributes dialog. So we'll just spend a few minutes on it, okay? So assumptions for this seminar, so you know where we're starting. I'm assuming you already know how to run a basic SQL query in ArcGIS. For example, to say, select all of the polygons where the land cover column is equal to deciduous forest. So you have to already know how to build that. And you can build it in the select by attributes dialog, right? Some column equals some value. If the value is a text string, you quote it. The interface will do that for you, but you need to know this when you slide that slider over and you start messing around with it. I'm also going to assume you know how to use wildcards with the like operator. Select all the records where the land cover column is like %forest%. The percent is the wildcard, so it finds anything that contains the string forest, like deciduous forest or evergreen forest or even forest gum, right? So you have to be careful when using those wildcards. Where you're going to see that in Pro when you're over here, whoops, and you do that select by attributes and you build the query. For example, select all of the addresses where the I don't know, the name contains the text, and you put some text in here like forest. When you slide the slider over, you'll see that the actual SQL query uses the like operator. So let me make that a little bigger so you can see it better. And the percent sign. See, those are wildcards. So I'm going to assume you already know that. You guys who are migrated over from old ArcMap, you will know this well because in ArcMap we had to type those out, right? But in Pro, it's a little hidden from you because you have this nice interface for building these queries and also in AGOL and Portal. So if you don't know those this basic functionality, I can help you with that. You can come to our intro class. But for now, we need to make some assumptions to know where to start this conversation. I'm also going to assume you know how to run queries using and or. For example, select all the parcels where the land cover column is like percent forest percent, or the land use is equal to agricultural grazing. Okay, again, those are things we cover in our intro class, so I'm making the assumption you know those. If I go over here, it's when you build one query, city equals Olympia, and then you add to that another clause, and I don't know, let's say the zip code is equal to something else. Apparently, I don't have zip codes in there. Let's try a different one. How about total acreage is less than 10 acres, right? So in this case, both conditions have to be true. You could switch that around and say or, and then either condition could be true. But you can slide the SQL slider over and see that the and or the or gets placed in there. It gets a little more interesting when you add multiple clauses where this is true or this is true or some other condition is true. So I'm going to say where the building value is greater than $200,000, right? So what if I do this? I'll say select all the parcels where the city is Olympia and the total acreage is less than 10 acres, or any other parcel where the building value is greater than 200,000. This gets a bit complicated, not complicated, but you have to pay attention so you know exactly how this is going to get evaluated. Does the city have to be Olympia and then either of these two conditions are true? Or is it the way that I originally read it? City is equal to Olympia, total acreage greater than 10, or any other parcel where building value is greater than 200,000. In fact, it's going to be that second way because the and is greedy and it grabs the two expressions on either side. So these two, well, both have to be true or any other building that meets this criteria. You can change that just by grabbing these two guys and pushing them over with this tiny itty bitty button here that groups those two. So now the city has to be Olympia, and either one of these two conditions can be true for me to select the parcel. Okay. So I said, I said, I'm assuming you know that all of that bit, but then I went ahead and showed you anyway. So just make sure you understand those things. Um, those are not going to be covered in this little webinar any further. Okay. Always reach out if you have questions, though. Yeah, so you can have and or in there. And I'm also going to assume you know how to use not in a query. So you can say, let's go down to the middle one. Land cover is not like forest. So that negates the query, right? Everything that doesn't contain forest. Or the top one, it looks a bit weird, but you can type it this way. Not land cover like forest. Now, if you build this query in your little query builder in Pro, it's going to put it the second way. But if you're typing this in code or you're pulling samples off the internet, you might see the not tacked on the front there, and that's totally fine. That negates the expression as well. And this one says land cover is not null, so find the polygons where I actually have a land cover value. So these are the sorts of things we cover in our Intro to Pro class. But if you're not familiar with these things, just take a little time to practice them in Pro. So let's go on. So those are the assumptions. That's where we're starting in this conversation. So let's talk a little about that SQL syntax. Wait a minute, let me back up. All of these were called where clauses. All they're doing is filtering the number of records that get returned to the calling routine, right? It's just filtering records. But as I said, there's a lot more to SQL syntax. Pro lets you see, and AGOL and Portal let you just see the where clause. But real SQL syntax looks like this. You have a statement at the beginning, like select, but there are others. But in this webinar, we're going to talk about select, okay, about pulling columns and records from a table. There are others that update features in a attribute table, like update records in a table, or some that update users, for example. But we're going to talk about the select statement. So the SQL select statement goes like this. Select some columns from some table where some condition is true. So see, there's a lot more there. In Pro, we're just getting the condition. But if you say select star, that means select all the columns from this table where this condition is true. And it gets really cool because you can put lots of columns, you can put lots of tables, you can put lots of conditions. So if I say select star from Arizona hiking trails where saguaro average height is greater than 50 and scorpion sightings is equal to 0, that's where I want to go hiking, right? So both of these conditions have to be true. Really tall cactus, really 0 scorpions. Select all the columns from this table where this condition is true. So that's the structure of a basic SQL statement. So if you're writing Python, you're going to call SQL, pass a SQL statement over to retrieve some data. You're going to need to put the entire select statement in there, depending on the Python functions that you use, really. So, but you can write more interesting SQL, see, because if you say select star from Florida vacation spots where alligator sightings per day is less than 100, select all these columns from this layer where this condition is true. That's great. But what if your attribute table doesn't have alligator sightings per day? What if it just has alligator sightings per year? And you're interested in, yeah, but on average, if there's less than 100 per day, I might go because Florida, there's a lot. So you can dissect the SQL, right? The thing on the left of the operator. And when I say dissecting SQL, in this case, I'm really talking about dissecting that where clause at this point, okay? We'll dissect the rest of SQL later, but dissecting that where clause. The thing on the left of the operator gets whittled down to a value, and then the thing on the right side gets whittled down to a value, and those two values are compared by the operator, in this case, less than. So this is really cool because you can do some manipulation of the data on the fly in your SQL statement. So if I don't have alligator sightings per day, but what I have, I can do math over here on the left side of the left side of the operator, right? So it can this left side can be columns, can be SQL functions, calculations, subqueries, or any combination of these. So I can say alligator sightings per year column, go grab that column that I do have, divide it by 365, and then see if it's less than 100. If it is, then I might go tour there, right? So I don't have, sorry, I don't have an alligator sightings per day column, but I do have one called alligator sightings per year. So I just do the math on the left-hand side, see if it's less than 100. The right-hand side can also consist of column names, SQL functions, calculations, subqueries. And the expressions on both sides are evaluated or whittled down to a value and then compared. And this is magic, right? It's not magic, but this is cool because it can help us back here in the ArcGIS Pro world too. Um, oops. Okay, so here, oops, sorry. Here's my table. So suppose that I'm interested in the value of this land, but what I want to do is I want to assume, I think this data might be old. Maybe I got it a few years ago. And I want to assume all these properties have increased in value by 10% since since I collected this data. So I'm going to run a query and try to find all the land that's valued more than $1 million. But I'm going to, well, I better, yeah, let's do 1 million. But I better no, maybe I better do 200,000. I'll do 200,000. But again, I think the data is old, so I want to increase all the property by 10% before I check that. So I'm going to add a clause where the um, land value is greater than $200,000. But again, I need to increase that. So I'm going to slide the SQL slider over and I'm going to say, take the land value and multiply it by 1.1. So increase it by 10% and then see if that total is greater than 200,000. See? Again, I'll make that a little bigger so you can see it better. So this bit can be any sort of equation, adding columns together, extracting date values, converting data types, all of that. Right? Now, even after you've made an edit like that, you're not going to be able to slide the slider back over because it doesn't just once you go back to that main interface, it doesn't know how to deal with that fancy code you put in there, right? So keep that in mind. If there's this left-hand side of the query you can manipulate. So calculations, plus, minus, divide, modulus, SQL functions, upper, substring, current date. There are a bunch of functions that will manipulate that data on the fly. These things can all go on either side of the comparison operator. And we don't have time in this little bitty webinar to talk about all the possible SQL functions, but well, first of all, hopefully you'll come see our class and we'll help you with that. But what you can do is as you start typing in here in this query builder, once you've slid the slider over, you see it gives you some code completion. It gives you a little bit of help with those functions, what functions are available. Okay, so all of those things can go on either the left or the right side of that operator. So for example, here are some valid SQL statements. Take all the home value in 2010. That's what we just did, right? Basically taking a home value, multiplying it by 1.1. But in this case, on the other side of the operator, we have a different home value. So what we're doing, we're taking the value of the homes in 2010, increasing them by 10%, and seeing if that's less than the 2015 home value. That means that's going to select all the houses that have increased more than 10% since 2010, between 2010 and 2015. I know that's 10 years ago, 11 years ago, but so that's pretty powerful, right? Without without having to manipulate, sorry, without having to edit the data. So that means even if I don't have write permission to the table, I can still do this kind of manipulation. And it's not even requiring Arcade or Python, it's just SQL. Here I'm taking the year 2015 and I'm subtracting the year built from the homes and I'm seeing if that is greater than 50. So I'm trying to find all the houses that were more than 50 years old back in 2015. I don't know why I'm using 2015 in this year, but so 2015 minus year built. Find all the houses that were over 50 years old in 2015. So there's just a few examples. Okay, let's see what else we can do with SQL. So here's a little table. It really can't read. It's tiny, but suppose you have case problems, right? You have some values in your attribute table that are uppercase and some that are lowercase, and you need to query them. Well, you can go to your field calculator and fix that with an Arcade or a Python expression. But again, what if you don't have write permission to the data? So you can do this, see? Select where upper of the city is not equal to the city. This will find any cases where the city is not in uppercase, because what this does, right, it grabs the city value, forces it in uppercase, and then compares against the original value. You forced it into uppercase. Let's say it's Houston. So over here you have uppercase Houston, and here's the original Houston. If that's not uppercase, they don't match, that record's going to be selected. So it helps you identify where the casing problems are. But just for a simpler example, if you just want to query, let's push this back over. So if you just want to query where, for example, the city is equal to Olympia, I mean, it's pretty easy because a lot of databases now, these queries are case insensitive. But if you're not sure, if you are querying a database or a data type that's case sensitive, you can just put the slider over here and force the city into uppercase before you compare it against your uppercase match. So this way, in this data set, it doesn't matter. They're already all uppercase and they're all only Olympia. But in real life, if that city was uppercase, lowercase, title case, whatever, we grab it, force it to uppercase, compare it against our uppercase match. And there we go. We don't have to stress anymore about whether something is uppercase or lowercase or mixed case. Another example, what if you want to check, like, suppose you have zip codes and you're trying to figure out, you think all the zip codes are 5 digits, but notice you think there might be some that have tacked on the extra 4 digits, and you just want to figure out, do we have any zip codes in here that are not exactly 5 digits long? Well, there's another nice little function called character length. So you can just do character length of the zip column where it's not equal to 5. So that'll return anything that has a zip code with those extra 4 digits on the end, but it'll also find any zip code that maybe there's a typo and it didn't get a full 5 digits. So again, grab the zip code, find the character length, how many characters are in it, compare it to 5. Find any one that's not equal to 5 characters long. So there's another example. Suppose you have your data in your attribute table that is in meters, but in your brain you think in feet. And so you want to find, let's say, all the sidewalks that are longer than 100 feet. But again, the data is in meters. All you have to do is take the length meter column and multiply it by the conversion factor on the left-hand side of the expression, right? So do the math on the left, see if it's greater than 100 feet. I use that a lot on shape length and shape area. Because, it's often in feet or meters, and I'm thinking in miles or kilometers. And here's another one. This is a little bit more unique, but it uses a function called the mod function. Mod stands for modulus. It's a mathematical expression where we take it returns the remainder after a division. So basically, I'm saying here, take the modulus of the contour value in my contour table, right, an elevation, divide it by 5,000. And if the remainder is 0, that means that contour line is evenly divisible by 5,000. And this lets me create index contours, right? So create index contours. Let me show you a little example of that real quick. So here you're seeing some contour lines in a little portion of near Kentucky. Part of it's in Kentucky anyway, along the Ohio River. Those look like index contours, but they're not. It's just really steep slopes if I zoom in close. But these are 1-foot contours, and it doesn't make sense for me to always show every single contour. What I'd like to do is say, let's pull out every 10-foot contour out of this, right? So what I'll do, I'll take this contour layer and I'll copy it, and I'll paste it back in the map. So let me turn off the original one. So this guy up here, I'm going to give it slightly thicker outline. Oh, sorry, I should show you what I was doing. So I went into the symbology and I just gave it a slightly thicker outline, maybe a slightly darker color as well. So that's fine. But what I'm going to do is I'm going to filter these. So we're only seeing the lines that are evenly divisible by 10 using that modulus function. And I'll do that with a definition query, which I can get to through properties here. And I can go into the definition query tab and build a new definition query. And my query is just going to say, select all the records where the contour value is equal to 0. But of course, that's not what I really want to say. I really want to use the modulus function. So I need to slide this SQL slider over there. And I'm going to say, oh, actually what I meant was where the mod of contour, comma 10, right? Take contour line, divide it by 10. If the remainder is 0, I want that line in my index contours 10-foot layer, definition query, I mean. So I'll apply that, I'll say okay, and now you see I'm just getting the 10 foot. So if I turn the original ones back on, you can see the little ones in between, right? Okay, so I've been talking about select by attributes, but of course you can use the same SQL techniques in a definition query. All right, so those are a few of the functions. Here's another thing you can do with SQL. You can use an in operator. So that's not a function, it's an operator. But instead of saying something is greater than or less than a value, you can say, for example, select all the streets where the street name is in, and you can provide a list of values with inside these parentheses. And so in Pro, that's done. Let's go up here to these parks. That's done with select all the parks where the type includes the values. That's the in operator. And then you could just go and, tick off the ones you want, right? So fine, why do I need to care about in if I'm doing SQL? Because if you go over here, then you can, upper the type is in this list. Now you don't have to worry about whether it's uppercase or lowercase, or you can do whatever kind of manipulation on the data you want over here, right? So you can use the interface to build the basic end statement, but then you can manipulate it. I can even put functions in here. So that's the in operator. And then one more, you can use a substring function. That's a little mixed up. Sorry, this slide's a little mixed up because I have one operator and the rest of these are SQL functions. But anyway, substring pulls out a portion of a string. So here I'm searching for substring of API num. I work a lot in the energy industry in Houston, and for oil and gas wells, they have a American Petroleum Institute number, and they look like this. The first two digits tell you what state the well is in, Texas, Louisiana, Colorado, and then the next three tell you what county the well is in. And then there's some digits on the rest that just are a unique identifier. So if I want to pull out everything that's in state 17, I need to pull off the first two digits. Well, I do that with a substring function. And yes, I could do it with a like operator, or I could do it nowadays with a begins with in the interface. But again, if I'm passing this in through Python, or if I'm going to manipulate this in more detail, it's good for me to understand the functions in the background. So you do substring. So I'm taking substring of API number from character 1 to character 2. Sorry, that's not exactly right. Substring the API number column from character 1 for 2 characters. So start in position 1, grab 2 characters, and see if that's equal to 17. And if so, I want that record. So this is just giving you, I just wanted to share with you some different ways that you can use SQL with a little introduction to some of the functions. This is just barely scratching the surface. So check out SQL functions if you're interested in what else you can do. There's a couple more things just quickly. We can compare concatenated fields. Here I have a street full name, like Callisto Boulevard. I also have a street name and a street type as separate columns, and I'm just trying to see, is it true that if I add up the street name and the street type, I always get the full name? Or are there any cases where there's a mistake in the data or inconsistencies in the data? So to do that, I want to check, is this field actually the concatenation of these two other fields? I use the string concatenation operator in SQL, which are these two vertical pipes, these two vertical bars. So I'm saying select all of the records where the full name is not equal to the street name plus a space plus the street type. So not all the time you need it, but occasionally that's really handy. I used it a lot when I was cleaning up some 911 data. Anyway, just to give you an idea, some of the things you can do in SQL. This is just an overview. And finally, we can do subqueries. So subqueries use that in operator that I showed you earlier. Remember, we said street in, and we provided a comma-separated list of streets. Well, the cool thing is you can instead of providing that comma-separated list of streets yourself, you can put another SQL statement in there that goes and retrieves that list of street names from some other data set. So, for example, suppose I have a little data set called 2015 repaved streets, and it's got like 50 streets in it. But I've got all the streets in Houston over here, and I want to say, in my main streets layer, select all the streets that were repaved in 2015. So I'll say, select all the records where the street is in, select the street name from the 2015 repaved street layer. See, that's cool. And you can't build that in the Select by Attributes interface. But once again, you can build the starting point, you know, some column. I don't have streets in here, but some column is in, includes the values, and then you slide the SQL over, and then in here you have to type your other select statement, see? And for that to work, I think, if I remember correctly, the data sets have to be in the same geodatabase, and I don't think it works on shape files. Here's another example using a subquery that's got a function in it. So I'm saying in my data set, let's say Texas cities, select all the cities where the population is greater than, and instead of putting a number in here, I'm going to say select the max population from Florida cities. So go to my Florida cities data set, grab all the populations, and then pass those into this max function, and then find the biggest population, pass it back to my query. So this is a subquery using an in. This is a subquery populating the right-hand side of a Boolean expression where I'm checking for greater than or less than or equal to. And both are totally valid and used all the time. It's really powerful, right? But again, in this case, my Texas population city, my Texas cities and my Florida cities would need to be in the same geodatabase for this to work. And you've got max, min, standard deviation, sum, all of those are valid mathematical functions in SQL. And you finally, I said finally before, but also I just want you to know you can nest functions. So here I'm doing a substring on something, but the substring is going to be from the operator field. We need to spell this out a little bit. Let me put all of these in so we can see it. So basically, I don't know for sure how many things I need to pull out of this operator field. Okay, so what I'm going to do is I'm going to take the agency column and I'm going to find out how long it is. So that's the character length function. So it tells me this one is 1, 2, 3, 4, 5, 6 characters long. That one is also 6 characters long, but maybe some are not 6 characters. So I'm getting the character length of agency and I'm taking off 2. So 6 minus 2 is 4. Okay, so that says start at position 4, 1, 2, 3, 4. Start on the D and go over 3 characters. 1, 2, 3. So I'm getting just DNR. I'm dropping off whether it's US or Texas. I'm getting it DNR. So now I'm selecting all of the records where if I go to the operator and I pull off the last 3 characters, right? It's going to say DNR. That way I don't care if it's US or Texas, I'm still going to get it. So you're going to have to think about this one a little bit if you haven't seen this, but just look at the functions. I should have numbered these, but the innermost, the very first one to look at is the character length of the agency. Subtract 2 to get rid of those first 2 characters. And that gives you the position where you should start. Try some of these. They're really powerful. If you have character data like this where you need to pull out a portion of it, and again, you don't have write permission to the attribute table. Okay, so that's my little introduction to SQL. If you want to learn more, go to teachmegis.com and register for our upcoming course. It's called Introduction to SQL, Querying a Database. We do the whole class in Microsoft Access so that you can get used to the full SQL statement, not just the where clause. So we do the select statements of various types. But anyway, you can look at the course outline. It's out there at teachmegis.com, or reach out to us. Here's the email address, info@teachmegis.com, or give us a call. Our classes are either offered online, so you can log in remotely and take the class, or you can join us here in our Houston Training Center. You can also have us come out for a private class if you've got six or more people who are interested in taking the class. Thanks for watching. I hope you found it useful.